Hello everyone, my name is Lucas Davis and this is Team 13's first year Engineering Design Day project. When we first got this project, we had the idea for a skee-ball inspired pinball machine. Upon reviewing the materials list, what we had bought and what we had not already gotten, and looking at the designs we had, we decided to pivot. We created the new idea for a custom Plinko ball machine. The Plinko ball machine uses the plunger from the pinball machine to spring load the ball into the array, utilizing elastic tension and gravity to get the ball into the scoring zones. Throughout this project, we created a few designs, weighing off of ideas from the pinball machine themselves and other Plinko machines that we had found online. I will show how this works now. The human interaction pulls the spring back, the spring bounces the ball into the thing, and the elastic bands are there just in case the ball goes a little too far to one side. Gravity finally bringing the ball down to the scoring mechanism. For FEDD Day, we did have an electronic scoring mechanism, but we have since returned that to NCSU since it was a borrowed system.
I'm going to talk about the CAD design and our electrical component part of the project. So here's our original CAD design we had for the skee-ball machine that we were going to do initially until we ran into time constraints. But we originally had a skee-ball machine. This is the CAD sketch of it, and due to time constraints, we pivoted to a Plinko game, but it was already convenient since we had implemented springs into the design, and we had a plunger to pull the spring back. The original electrical component functions were also simplified at FEDD Day due to time constraints and due to things such as the makerspace not being available for use at the time. So I'm going to walk through the electrical component. So I have a video of the scoring system before FEDD Day, which I will show in a second, but here is the code for that. It was written in MicroPython using Thonny. We used a Raspberry Pi Pico, and as you can see, the code is very simple. We have a display, we have a jackpot function, and we have a point system for each of the scoring zones. So if you got over 500 points, then you wouldn't have to retry, but if you got less than 500 points or less, then it would ask you to retry and you'd be able to play again until you got a higher score.
One of the biggest challenges we had was time. We were on a tight schedule, so we didn't have much room to redo parts if something didn't work. We had to make decisions quickly and keep moving forward. Another issue we faced was materials. Some of the things we planned to use were not available in the market space, or some parts are already taken by other teams. So instead of waiting, we just worked with what we already have. We changed some parts as it aligns with our budget. To deal with that is we focused on testing and adjusting as we went. For example, we didn't get things like the ramp angle or spring strength perfect the first time, but after that we kept tweaking them until the game worked properly and perfectly. In the end, these challenges taught us how to be flexible and think fast, and we learned it doesn't matter if it's perfect as long as it's worked properly and aligns with our goals.
Tips for the first year engineering project and things that I would do differently if I had the chance. Number one, start early. Get started reading on the project requirements, resources needed, and any other information needed. Number two, team communication. Keep in contact with your team to ensure you're all on the same page. Number three, secure resources. Identify and secure the resources / materials needed for the project ahead of time to prevent cramming. Number four, set deadlines. Set group deadlines ahead of the deadlines given by the instructor to ensure you get the work done and there's time to fix the project if needed. And the fifth and final one is optimize workflow, evaluate your team dynamics early to find the most efficient collaborative process, whether that's meeting online or in person. Thank you.